So let's talk about HSM, hardware security module. You know what? Encryption is meant to be complex, isn't it? Encryption or any kind of cryptography is meant to be complex. It's not meant to be easy, because if it is easy, then the attacker can easily, break it, and then there is no security. End of the day, the strength of cryptography depends on certain factors, and number one is the algorithm, or you can call it as a cipher as well. If you are using a weak cipher, it is easy to break cryptography, right? So we always want that we should be using a cryptography which is not being broken and it is strong itself. When it comes to strength of an algorithm, it is the work factor. What is the work factor? Work factor is the aspect where how much time and the effort it requires for a attacker to break a cryptography. So all the algorithms are frequently tested by security researchers to identify what is the work factor. When the work factor, because of enhancing technology and cloud computing and the AI coming in, it is very easy, right? The way the technology is increasing, the work factor will reduce, because attackers are now more smarter. They can use systems with very good configuration, and something which they were able to achieve in 3 days, now they can achieve in 2 days. So identifying the work factor and on a constant basis is very, very important, right? This second aspect of cryptography which keeps it secure is also about the implementation. The overall design and implementation of the entire cryptography is very, very important, and that is also there is a specific term also which we use, that the cryptography should be very, very random. I'm just forgetting that particular name on top of my head. That's a very important topic. That's a very important term which you should understand. I will let you know the moment it comes to my mind. Okay. Entropy. That's the word, right? So entropy is also very, very important. Entropy is the amount of randomness which an algorithm can bring in for you, and entropy is also impacted by implementation as well. If you have a strong cipher but you are not implementing it right, that means the kind of transposition and substitution and those kind of things, if they are not happening in a proper implementation way, let's say cipher blockchaining or those kind of stuff, then your cryptography may be weaker, right? Another important aspect when it comes to cryptography is key management. Right? And key management is so vital, because most of the time when we talk about cryptography, we are often lost out into complexity, but we forget the key, right? You brought a big lock at home and you are just lost with the heaviness and the strength of your lock, but the key is something which you undermined. You just kept it casually, and that can lead to the entire system to fail. So key management is also very, very important. So how do we manage it? How do we manage these keys? How can we make sure that everything is processed in a very safe and secure environment? So for that, one of the solution which we have is called as HSM, hardware security module. This hardware security module, as the name says, it's purely hardware. And you know what? Even though there are a lot of solutions available and they also call it as software security module, they can never compare with hardware security module, because hardware security module is the safest and the fastest one. No chances of too much of vulnerability and those kind of stuff. So a HSM is a particular device, a hardware device which manages your keys. So it has the storage and the capability to store your keys in the most secure way, and at the same time it also provides you an environment where the particular cryptography operations can happen in a secure way, right? When we store the key in a HSM, they are normally key encrypting key, KEK. We call it as key encrypting key. That's very, very important. And these HSM keys has to be further secured in a much more, with much more security. That's the key control out there. Okay. Now, these HSMs, if you are doing a payment transaction today, you might not realize how many HSMs are being used before the transaction goes from your point of sale device to your issuer bank, because all the different you can say bodies, or you can say these payment gateways and other people who comes in between, right? They have HSM implemented because it's a framework requirement. They have to get compliant with the framework, and they have to implement these kind of frameworks, right? For example, okay, we'll talk about that later. First, let's talk about HSM itself. So you understood that HSM is not only processing only a few cryptography operations. They are used for volume, for a big volume of transactions which are happening, and where there is cryptography is involved heavily. So it maintains the key, at the same time it has the environment to process everything inside it. It also has its own processing power. The device has its own processor and everything. They are not based on an external processor or anything. They are all combined together. They don't want to use any resources from outside. So a HSM, in a literal sense, is a kind of device which is like a black box. It is like a black box. You cannot see what is happening inside a HSM. What you can only provide is data, the data you want to get processed, and the commands, EC commands and all these kind of commands, right? So the moment these two things are getting inside, they are processed. You have no visibility out of it, and the system process it and just give you the final outcome, let's say authenticated or not authenticated kind of things. They are so crucial in the overall scheme of things nowadays that there are very strict standards which are applied for HSM, and normally good HSMs which are there, very, very current HSMs, they are FIPS, Federal Information Processing Standard, either 140-2 compliant or 140-3 compliant. So that's how HSM actually do all this. Just a quick thing, if you are still not able to relate to the concept better, let me give you a just 2 minutes roundup. What is the actual implementation of HSM? So the moment you go to a let's say a merchant, let's say you go to Starbucks, and then you go and purchase a coffee, you swipe your credit card, and the moment you key in your PIN, right, your debit or credit card PIN, this particular thing actually go to the nearest you can say some kind of gateway, or you can call it as a switch. So this particular switch relates to the merchant bank, that is called as a acquirer bank. So this switch or this particular software or system has been put up by your acquirer bank. This entire thing, to read your information out of this, what they do, they actually have a kind of, they divide this as a zone. So a particular zone 1 will have a symmetric key which will be shared only by these two parties. So they, based on this symmetric key, they are going to decrypt your transaction. They are going to read this transaction to actually process it further, and then they are going to encrypt it again for the next hop. Next, it might go to, let's say, Visa switch. Let's say you are doing a Visa card payment, and then this goes to a Visa switch. So in this Visa switch, this will be a zone created between you and Visa, right? And this is where you are using a symmetric key between these two parties, which is highly secured. Again, in HSM, all these operations of decryption, reading and encryption all happens within the HSM, because it is related to payment. You cannot take any chances, right? And then From Visa, it might go to acquirer bank, it might go to issuing bank, which might have its own system, but again a zone key will be shared between them, and this zone key and the encryption and everything is getting processed everything in HSM. Then only your issuing bank will see your transaction, will authenticate your transaction, and if you have sufficient fund in your bank, then only it is going to clear the transaction, and then it will flow through the same route and get back to this, and then merchant will be happily giving you a payment receipt. You know the role of HSM in this entire stuff. Wherever your pin, your card pin is going, that is going encrypted. It has to be decrypted. It has to be then again encrypted for the next hop. All this happens, but everything happens within HSM. So in payment industry, HSM plays a very, very big role. So I hope this gives you just a feel of how important is your HSM as a device for managing your transactions and everything, right? So that was HSM for you, right? In the next video, we'll see something else.